I'm Algebra Annie, and I am here to help you be successful in your algebra class. Try to be a rainbow in someone's cloud. Amaya Angelou. Our learning target is I can use multiplication properties of exponents to evaluate and simplify expressions.
Now we are looking at multiplication properties of exponents. And I want to take this chance to investigate one of our rules. I don't want to just give it to you. I want to see what would this look like with our prior knowledge from semester 1 of algebra, and can we see why the rule works the way it does. So if I just wanted to simplify our first problem, 2 to the 5th power. If the exponent is a 5, that meant that this number right here, the base, was being multiplied together 5 times. So that means we have 5 things being multiplied together. So I have 1, 2, 3, 4, 5. Well, which 5 things are we multiplying together? It's this base of 2. So I have 1, 2, 3, 4, 5. Here are the 5 times that this 2 is being multiplied together. Well, now it's being multiplied again by 2 to the 6th power. By the same reasoning, the 6th power meant there's 6 things being multiplied together. 1, 2, 3, 4, 5, 6. And what 6 things are those? It's the 2. So I'm going to put a 2 in each of these. And these are my 6 things being multiplied together. Well, I see nothing but 2's. So how many times were my 2's actually multiplied together? Well, I saw 5 of them here and 6 of them here. So I see that I have actually a total of 11 2's multiplied together. So 2 to the 11th is my answer. I saw 11 2's multiplied together. So let's go here and do this problem. A to the 4th power meant that I had A multiplied together 4 times. So I had 1, 2, 3, 4. There's my 4 A's, and then it's supposed to be multiplied to B to the 5th, which meant I had 5 B's. So 1, 2, 3, 4, 5. So there's my 5 B's. And that's then multiplied to A to the 2nd, which meant I had 2 A's. Is there a shorter way to write this? Well, I see A's here and A's over here. Well, if I multiplied A 4 times over here and another 2 times over here, how many times did I actually multiply A here? I multiplied A a total of 6 times. And then B right here was multiplied together a total of 5 times. Well, instead of writing it out this long way we did each time, is there a shorter way to look at the exponents and get the number we needed? Well, here we saw that we had 4, because there were 4 of them. And here we saw there were 2, because there were 2 of them. And we just went ahead and we added the 4 and the 2, and we got 6. So an easier way to do this would have been just to add the exponents, and we would have gotten the same answer instead of writing out long. So it appears as though our rule is to add the powers. So let's go ahead and check out what the book says. So here's the book's rule. The book says the product of 2 powers with the same base. So I see the same base being multiplied together. That would equal that base, the same exact base, they're all bases of 6, so it's the same base, raised to the sum of the exponents. So the same base raised to, they just added the powers. So yes, our rule is correct. We just add the exponents. So let's see if we can apply this rule to 3 of our example problems. So example problem number 1. I see a base of y with an exponent of 2. I see a base of y with no exponent. Well, every variable has an exponent. If it's not written, we need to be in the habit of writing a 1. And then I see a base of y with an exponent of negative 4. They all have the same bases of y. So if they all have the same base of y, we're going to go ahead and we're going to combine all of these. So all of the bases of y, I had an exponent of 2, which meant that was multiplied twice. Exponent of 1, so I had to multiply 1 more time. And here's an exponent of negative 4. So now I just need to add all their exponents together. So I have y to the 2 plus 1 is 3, plus a negative 4 is a negative 1. So I went ahead and I added all my powers. I followed this rule exactly and I'm done. But this needs to be further simplified. My directions were to simplify it. It needs to be in simplest form. I know that I cannot have a negative power. This negative exponent is touching the entirety of y, which means this entirety of y is on the wrong side of the fraction. So here's my fraction line. If he was on the top and not very happy there, I need to put him to the bottom. He is now very happy. You cannot have an empty top, so you need to fill it with a 1. And now I'm done. My simplified answer is 1 over y to the 1st power. Let's go ahead and try it for number 2. I see same bases of 7's. If they're the same bases of 7s, I can add their powers. So that had a power of 8, and that had a power of 4. So same base of 7 had a power of 12, which means if I were to write this out the long way, the 8 times that this was multiplied together and the 4 times that this was multiplied together would show me a total of 12 7s multiplied all together. And then I'm done. Let's go ahead and simplify the third problem. I see a base of m. He doesn't have an exponent. He really should. So I need to get in the habit of writing a 1. Base of m with an exponent of 1, base of n with an exponent of -4, and a base of m with an exponent of 4. Bases need to be the same. So base m can only go with base m. So I'm looking at only my base m's at an exponent of 1, and I need to add it to the exponent of 4. My base n can only go with base n's. There is no other base n. So my base n is by himself. He's done. So I have m to the 5th and n to the -4th. Technically, we're done with this rule, but you need to further simplify it. You cannot have a negative power. This negative exponent is only touching the n, so the n is the only thing that needs to move. So he moves to the other side of the fraction, and he's done. So we're just going to practice our rule a couple more times. I see a base of 3 with an exponent of -3. I see another base of 3 with an exponent of 4. Base 3's are only allowed to go with base 3's. So looking at only my base 3's, the exponent of -3 needed to be added to the exponent of 4. Base 5's can only go with base 5's. So if I'm only looking at my base 5's, the exponent of 8 needs to be added to the exponent of 2. I did my base 3's. I've gone and done my base 5's. There are no other bases to do, so let's finish simplifying. This is 3 to the -3 plus 4 is 1. And base 5 to the 8 plus 2 is 10. So I have finished simplifying. This answer is 3 to the 1st times 5 to the 10th, and you're done. So let's go ahead and look at our next one. This variable needs an exponent. If it's not written, it's because it's a 1. So I see base x, a base of x, and a base of x. Means I need to combine all of my base of x's. He had a power of 1. He had a power of a -1. He had a power of a -3. And he had a power of a -4. So all the base x's got added together. Of my base x's, I had a 0 and -7. I cannot have a negative exponent, so I need to finish simplifying it. The entire x needs to be moved to the other side of the fraction. So my answer is 1 over x to the 7th. And I'm done. Now, how can we apply this rule to problems that are written in scientific notation? I have a scientific notation problem being multiplied to another scientific multiplication problem. So I just see a number times a number times a number times a number. So if we wanted to write this out a different way, I saw a number times a number times a number times a number. I see nothing but multiplication. So we can actually apply the associative and the commutative properties, and we can rearrange this. So I want to have my base 10s next to each other, which means my just regular numbers need to be next to each other. So here's 1.86 being multiplied to 5. I just went ahead and rearranged them so they're next to each other. And then my base 10s are next to each other. So how are we going to solve this problem? Well, in our rule, we know how to multiply when we have the same bases multiplied together. We know how to do this. That's the rule we've been doing. This is just a decimal multiplied by a 5. So we're going to grab our calculator, and we're going to actually use our calculator to solve this problem. 1.86 times 5 is 9.3. Now we're going to use the rule we've been doing to solve this problem. So I need to multiply it by their same base of 10s. So here's my base of 10. If they're the same base of 10, I add their exponents. So this is 5 plus 2. So this is a 9.3 times 10 to the 5 plus 2 is 7, 10 to the 7th power. Now, is this in scientific notation? I see a digit with a decimal, and then it's times 10 to a power. This is in scientific notation, except for we like to write the x as a multiplication sign instead of the dot for scientific notation. So this is my answer, and I'm done. So now it's time that we go ahead and investigate a new rule. So looking at this problem, let's use our semester 1 algebra skills, and let's see if we can solve this problem without a rule in place. So I see this entire parenthesis is raised to the third power. This third power is touching the entire parenthesis, which means I have 3 things being multiplied together. So here's my 3 things being multiplied together. What three things? Whatever the exponent was immediately touching, which was the parenthesis. So I have three parentheses being multiplied together. The 7 to the fourth power was in each of those parentheses. Well, now this looks very similar to a problem that we just did before. I see a base of 7, a base of 7, and a base of 7. I see all bases of 7s. Well, if they're all bases of 7s, in the rule we just finished learning, I can go ahead and I can add their exponents. So 4 plus 4 plus 4. 4 plus 4 plus 4 is 12. So I have 7 to the 12th power. And that is done, and I have simplified it. Let's go ahead and try another problem. So this entire parenthesis is raised to the 5th power, which means this entire parenthesis needs to be 5 times. So 1, 2, 3, 4, 5. Whatever's in the parenthesis needs to be written inside each and every single parenthesis. Well, similarly, it looks like just the rule that we learned before. They're all base 3s. So if they are all base 3s, I just need to add their exponents together. So 4 plus 4 plus 4 plus 4 plus 4. So a base of 3, if I added all these 4's together, I would end up getting 20. So I have 3 to the 20th power. Well, if I didn't want to do it out the long way like we did in our previous rule, how could we go from this problem to this? Well, I see that I drew 5 groups of exponents of 4. I had 5 groups of 4. Well, 5 groups of 4 gives me 20. That's multiplication. So if you multiplied their exponents together like this, you could have gotten 3 to the 20. Let's go ahead and see what the book says about the rule. So our book says a power raised to another power. So you have a power. He is raised to another power. This is going to equal that base, so it's the same base, raised to the product of the exponents, which means you multiply the exponents. So it looks like the rule that we discovered is correct. So let's go ahead and apply the rule to these problems. So I have a power raised to another power. This is called a power of a power because it's a power raised to a power. So I have two exponents next to each other. It's a power to a power. So I'm going to multiply it. So it's the same base of 6 and 0 times 3. 0 times 3 is 0. So this is 6 to the 0 power. We've gone ahead and applied this rule. But the directions say to simplify, which means you need to make sure your answer is in simplest form. This is not in simplest form. What is 6 to the 0 power? Anything to the 0 power we know is 1. So my final answer is 1. Let's go ahead and do our next problem. I see a power raised to a power. So I have the power of a power rule. Power raised to a power means I can multiply. So it's the same base of 5, and I multiply the exponents. 2 times 4. So same base of 5, 2 times 4 is 8. So I have 5 to the 8th power. And I simplified it. Our next one. I see a power raised to a power. So I can multiply the exponents. So I have 4 to the whatever 3 times 0 is. So I actually have 4 to the 3 times 0 is 0. So I have 4 to the 0 power. But as we know, anything to the 0 power is 1. So my answer is 1. Let's go ahead and try a couple more examples using our power to a power rule. So in this problem, I see that I actually have one power to a power rule being multiplied to another problem. So let's go ahead and solve this. We need to figure out what is this part first because there's a parenthesis. If there's parentheses, we actually don't know what we have yet. We need to finish it. So it's a power to a power, which means that base of x is raised to these exponents being multiplied together. And we haven't done anything to this yet. So this is still x to the 4th power. We're trying to figure out what is this parenthesis first. So this is x to the negative 15 being multiplied by x to the 4th. Well, now it looks like one of our old rules. I see same bases of x. Same bases of x means that I could add the exponents together. So that was a negative 15, and that was a positive 4. So I actually have x to the negative 11. Well, I know that I'm not allowed to have anything to a negative power. So this entire x is on the wrong side of the fraction. So he needs to go to the other side of the fraction. He's now a happy positive power. You cannot have an empty top, so you fill it with a 1. So my answer is 1 over x to the 11th. Let's go ahead and try the next one. I see a parenthesis right here. If I have parentheses, I really don't know what I have yet. So first things I need to do is try and figure out what do I really have right here. This is a power to a power. So I know the first thing I need to do is I need to multiply my exponents. I need to just carry this part down because at the moment I'm just dealing with this parentheses. So what was this? This is actually x to the negative 8th. And I'm just going to keep carrying down this part of the problem because we haven't done anything to it yet. Well, now it looks like a problem I did before. I see same bases of x. If I have the same exact base, I can go ahead and I can add their exponents. So I actually have x to the negative 3. But I know I'm not allowed to have a negative exponent. The negative exponent means it needs to be on the other side of the fraction. So I put it on the other side of the fraction. He is now a happy positive power. If the top is empty, you fill it with a 1. And I'm done. Our next problem. I see 2 sets of parentheses. I don't know what I really have. So my job is to figure out what does this parenthesis actually hiding, and then what is this parenthesis actually hiding. And then don't forget, we're supposed to be multiplying these guys together. So I see a power to a power. So for this parenthesis, I'm supposed to multiply the exponents. So this is 3 times 4. I am multiplying. I still am trying to figure out also, what is this parenthesis? This is a power to a power, so I know that I am going to be multiplying their exponents again. So if I finish this problem, this is a to the 12th. I am supposed to be multiplying, and this one is a to the 6th. The parentheses are gone, so now I can figure out what I actually have. This problem looks like one that I had very similar on the other lesson. So same basis of a's means that I could add their exponents, so I'm going to add their exponents. So I actually have a to the 18th is further simplified, so I'm done. So we have one more rule that we need to investigate. And we're going to, again, use our semester 1 skills to figure out what this is. This entire parenthesis is raised to the second power, which means this entire parenthesis should be multiplied twice. So 1, 2. Whatever's in the parenthesis needs to be put into that parenthesis. Well, now I see a negative 3 times an x times a negative 3 times an x. So I like to write it like this because then I can actually see what I have. Negative 3 times an x times a negative 3 times an x. Well, because of the associative and the commutative properties, I know that I can rearrange multiplication. So I'm going to put the negative 3's so they're right next to each other, and I'm going to put the x's so they're right next to each other. So looking at this, I can see that I actually multiplied that entire negative 3 twice, and I can see that I multiplied this x twice. Well, how would we have gotten from there to here? Well, this entire parenthesis was to the second power. I see that everything, the negative 3 was raised to the second, and that x ended up getting raised to the second. I see that each and every single thing in the parenthesis was raised to that power. Let's go ahead and solve this problem using our semester 1 skills and see if we notice the same pattern. This entire parenthesis raised to the third power, which means this entire parenthesis should be 3 times. So 1, 2, 3. Whatever's in the parenthesis needs to be put into the parenthesis. Well, 4 times p times 4 times p times 4 times p could be rewritten like this, so it's a little easier to see. And again, because of the commutative associative properties, I'm doing nothing but multiplication. I can rearrange it so it's easier for me to see. Well, I see that 4 was multiplied 3 times, and I see that p was multiplied 3 times. The 4 was raised to the third power. The p was raised to the third power. It looks as though if I have an entire parenthesis raised to a power, each part inside the parenthesis then needs to get raised to the power. So let's go ahead and see what the book says. All right, so what does the book say? The book says a product, which means you have something multiplied. So in here, I see I have 2 things in here. So if I have 2 things in my parenthesis, if that is raised to a power, then that is going to equal the product of each factor raised to that power. I see that the 2 was raised to the third power, and then that is then again multiplied by 4 to the third power. So it looks as though that everything inside is supposed to be raised to the power. And then they finish solving it. So we need to make sure that we finish simplifying them next time because we didn't do that before. So now looking at this, I have an entire parenthesis raised to the third power. According to my rule, each part needs to be raised to the third power. So this negative 5 is going to get raised to the third power, and this t to the second needs to get raised to the third power. So the negative 5 needs to be raised to the third, and that t to the second needs to be raised to the third. Notice that I put everything in parentheses. It's good habit to put everything in parentheses when you're doing this rule. So negative 5 to the third power. What does negative 5 to the third power mean? means -5 times -5 times -5. So either you know your multiplication skills or you need to grab your calculator. This is -125. Now this parenthesis, I see two powers next to each other. So this is going to be a power to a power. So this means I multiply them together. So this is t to the 2 times 3. So I have a -125, and that is t to the 6th power. Nothing else can be simplified, so I'm done. This problem, this entire parenthesis is raised to the 2nd power. This negative sign right here is not a part of the parenthesis. So that negative sign is going to chill right outside. This parenthesis is raised to the 2nd power. So that meant this 2 needs to be raised to the 2nd power, and this y needs to be raised to the 2nd power. This negative sign is not a part of this problem, so he's just going to chill out there again. What is 2 to the 2nd power? 2 to the 2nd power is 4, and y squared is already simplified. It's just y squared. So I end up having a -4y squared. So my final answer is -4y squared. It is in simplest form. I'm done. Next problem. This entire parenthesis is raised to the 3rd power, which meant everybody in this parenthesis needs to be raised to the 3rd power. So this -2 needs to be raised to the 3rd power, and this y needs to be raised to the 3rd power. I put my numbers inside of parentheses so I don't lose my negative signs. Now this -2 to the 3rd power is a -8. Y to the 3rd is already just y to the 3rd. There's nothing else to simplify, so you're done. So we just have 3 last example problems to be doing today. So in here, we have the entire parenthesis raised to the 2nd power. If your entire parenthesis is raised to the 2nd power, then everybody in the parenthesis needs to be raised to that 2nd power. So this x to the 6th is going to be raised to the 2nd, and then we are multiplying. This y to the -3rd is then raised to the 2nd. I see 2 powers next to each other. That is the power of a power rule, which means we're multiplying. So this base of x is to the 6 times 2. This is multiplied by, I see powers next to each other, so this is a power to a power rule. So that base of y is to the whatever -3 times 2 is. So I have x to the 6 times 2 is 12 times y to the -3 times 2 is a -6. Now we've appropriately applied our rule, but your answer needs to be in simplest form. This is not, because we still have a negative exponent. You're not allowed to have negative exponents. If it is a negative exponent, he's on the wrong side of the fraction, so he needs to move. This was a positive 12. He's fine where he's at. You need to leave him alone. This y was on the top. It did not like being on the top. You move him to the bottom. He's now a happy positive power. Everybody's in simplest form, so we're done. Our next one. I see a parenthesis here that I need to figure out what actually is, and that is being multiplied by. I see another parenthesis here. I need to figure out what that one actually means too. So we're going to be doing 2 separate problems kind of side by side, and they're still always multiplied together. So this parenthesis is raised to the 4th power. That meant everybody in here is raised to the 4th power. This y to the 2nd is going to be raised to that 4th, and this y to the 3rd needs to be raised to the 4th. That was this parenthesis. We are multiplying. What does this parenthesis actually equal? Everybody in this parenthesis is raised to the -4th, which means each part is raised to the -4th. This y to the 2nd power is raised to the -4th, and this y to the 4th power is raised to the -4th. So now we still have parentheses. Our job is to figure out what these parentheses actually are. So if I see the exponents right this close together, you multiply. So base of x is to the whatever 2 times 4 is. Exponents are really close together. So this is y to the whatever 3 times 4 is. We're multiplying. Exponents are really close together, so we're multiplying. This base of x is to the whatever 2 times -4 is. Exponents are really close together, so we're multiplying. So this is a base of y to the whatever 4 times -4 is. So this was actually x to the 8th. He was y to the 12. We are multiplying. This is x to the -8, and this is y to the -16. So we figured out what this parenthesis actually equals. It's a multiplication problem. And we figured out what this parenthesis actually equals. So looking at this, when 2 variables are next to each other, it's actually multiplication. When 2 variables are next to each other, it's actually multiplication. I see nothing but multiplication. I see a base x and a base x. So I can apply my other rule. I see bases of x. That had 8 times, and that one had a -8. So we're going to go ahead and add our exponents. I see same bases of y's. So here's my base of y. There were 12 multiplications there, and this one had a -16. So we actually had x to the 0 and y to the -4. You need to finish simplifying. What is anything to the 0 power? 1. So this is actually 1 times y to the -4th. What's 1 times y to the -4th? It's actually y to the -4th. Now, you cannot have a negative exponent. He's not happy where it's at, so you need to finish him. This is 1 over y to the 4th power, and then you're done. Our last example problem. This entire parenthesis is raised to the 3rd power, which means everybody in the parenthesis needs to be raised to that 3rd power. This x to the -2nd is going to be raised to the 3rd, and this y to the 0 is going to get raised to the 3rd. I see exponents touching each other, so I'm going to go ahead and multiply. This is x to the -2 times 3, and this is y to the 0 times 3. So I actually end up having x to the -6 and y to the 0. What is y to the 0? Anything to the 0 power is 1. So this is actually an x to the -6 times 1. What is x to the -6 times 1? Well, it's x to the -6. And then we're not allowed to have negative exponents. This needs to be simplified. So when I simplify it, I get 1 over x to the 6th power, and I am done.
What did we learn today? I can use multiplication properties of exponents to evaluate and simplify expressions, and I look forward to seeing you tomorrow in class.